Hello friends, welcome to Electrical Machine Class Lesson 8. In this lesson we will learn on the working principle, classification and the types of DC generators. In the video on basics of electrical machines we defined an electric generator as a machine that converts mechanical energy into electrical energy. An electric generator is based on the principle that whenever flux is cut by a conductor, an EMF is induced which will cause a current to flow if the conductor circuit is closed. The direction of induced EMF, and hence current, is given by Fleming's right-hand rule. Fleming's right-hand rule states that by holding the thumb, index, and middle finger of the right hand at right angles to each other, the index finger indicates the magnetic field, the thumb shows the direction of the conductor's motion, and the middle finger then points to the direction of the induced current. Thus in summary the working principle of a DC generator is as below. When the generator is driven by a prime mover, such as an engine or turbine, the shaft rotates along with the armature. As the armature rotates, the conductors cut through the magnetic field produced by the poles and field winding. An EMF is induced in each conductor proportional to the rate of change of flux linkage according to Faraday's laws of electromagnetic induction. The direction of induced EMF in each conductor can be determined by Fleming's right-hand rule. The induced EMF in each conductor alternates as it passes under different poles and is equal to the sum of EMFs induced in its conductors. The induced EMF in each coil also alternates as it passes under different poles. The split ring commutator, mounted on the armature shaft and connected to the armature, automatically reverses the connection of the armature to the external circuit. This commutator action ensures that the induced current flowing into the external load always flows in the same direction. Providing direct current, DC. Faraday's law of electromagnetic induction states that a changing magnetic flux through a circuit induces an electromotive force, EMF, or voltage in that circuit, with the magnitude of the induced EMF directly proportional to the rate of change of the magnetic flux. Now let us look at the classification of DC generators. They are 1. Self-excited DC generators. 2. Separately excited DC generators. 3. Permanent magnet DC generators. What is a self-excited DC generator? Is one in which the field magnet winding is supplied current from the output of the generator itself. Working principle. Residual magnetism in the iron poles produces a small initial flux. When the armature is driven by a prime mover and a small EMF is induced. This EMF circulates a current through the field winding, strengthening the flux. Stronger flux induces a larger EMF. This feedback continues until the generator reaches its operating voltage. This process is called build-up of voltage. Types. 1. DC shunt generator. 2. DC series generator. 3. DC compound generator. Note. 1. Requires residual magnetism to start building up voltage. 2. If residual magnetism is lost, voltage won't build up. 3. Output voltage depends on speed, field resistance and load. Now let us look at DC shunt generator. What is it? Is one in which the field winding is connected in parallel with the armature winding so that terminal voltage of the generator is applied across it. 1. Shunt field current, ISH equals voltage divided by shunt resistance. 2. Armature current, IA equals load current plus shunt current. 3. Terminal voltage, V equals output voltage minus product of armature current and armature resistance. 4. Power developed in armature equals product of output voltage and armature current. 5. Power delivered to load equals product of voltage and load current. Below is the circuit diagram of a DC shunt generator. 1. RSH equals shunt resistance. 2. RA equals armature resistance. 3. IL equals load current. 4. ISH equals shunt current. 5. IA equals armature current. 6. EG equals output voltage. What is a DC series generator? Is one in which the field winding is connected in series with armature winding so that whole armature current flows through the field winding and the load. They are rarely used except for special purposes, e.g., as boosters, arc welding. 1. Armature current, IA equals current through the series field, IS equals current through the load, IL equals total current, I2. Terminal voltage, V equals output voltage, EG minus sum of voltages through the armature and series field, I, RA plus RSE. 3. Power developed in armature equals product of output voltage, e.g. and armature current, IA. 4. Power delivered to load equals product of terminal voltage, V and armature current, IA or product of terminal voltage, V and load current, IL. Below is a circuit diagram of a DC series generator. 1. RSE equals series field resistance. 2. Raw equals armature resistance. 3. IL equals load current. 4. IA equals armature current. 5. EG equals output voltage. 6. V equals terminal voltage. Now let us look at DC compound generators. They are of two types. 1. Short shunt is one in which only shunt field winding is in parallel with the armature winding. 2. Long shunt is one in which shunt field winding is in parallel with both series field and armature winding. In a short shunt, 1. Series field current, Is equals load current, IL. 2. Shunt field current, ISH equals terminal voltage, V plus voltage drop across the series field, Is RSE divided by shunt field resistance, RSH. 3. Terminal voltage, V equals output voltage, EG minus voltage drop across the armature, ERA minus voltage drop across series field, Is RSE. 4. Power developed in armature equals product of output voltage, EG and armature current, IA. 4. Power delivered to load equals product of terminal voltage, V and load current, IL. In a long shunt, 1. Series field current, Is equals armature current, IA equals load current, IL plus shunt current, ISH. 2. Shunt field current, ISH equals terminal voltage, V divided by resistance of the shunt field, RSH. 3. Terminal voltage, V equals output voltage, EG minus voltage drop at the armature and series field, IA, Ra plus RSE. 4. Power developed in armature equals product of output voltage, EG and armature current, IA. 5. Power delivered to load equals product of terminal voltage, V and load current, IL. The below is the circuit diagram of a short shunt. As can be seen, the shunt field winding is in parallel with the armature only. RSE equals series field resistance. RSH equals shunt field resistance. Raw equals armature resistance. EG equals output voltage. V equals terminal voltage. IL equals load current. ISH equals shunt current. IA equals armature current. The below is the circuit diagram of a long shunt. As can be seen, the shunt field winding is in parallel with both the armature and series field winding. RSE equals series field resistance. RSH equals shunt field resistance. Raw equals armature resistance. EG equals output voltage. V equals terminal voltage. IL equals load current. ISH equals shunt current. IA equals armature current. Now let us look at separately excited DC generators. What is a separately excited DC generators? Is one in which the field magnet winding is supplied from an independent external DC source, e.g. a battery. The voltage output depends on the speed of rotation of the armature and on the field current. The greater the speed and field current, greater is the generated EMF. They are rarely used in practice. Now let us look at permanent magnet DC motor. Is one that uses permanent magnets instead of field windings to produce the magnetic field. No external excitation or field current is required. Working principle. When the armature rotates inside the constant magnetic field created by the permanent magnets, a voltage, EMF, is induced in the armature conductors according to Faraday's law of electromagnetic induction. E equals product of constant, K flux, phi and speed, N where E equals generated EMF. K equals constant, phi equals magnetic flux, constant in PMDC, N equals speed of rotation. Since the flux is constant, the generated voltage depends only on speed. Thank you for watching our channel. Please like, comment, share and please don't forget to subscribe. May God bless you.